Hello, 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 it's me, Panacotta Row, and welcome back to the streamer Row. We're gonna play some stationeers. So yeah. And for stationeers, we would like... We prefer a little bit of music. So, guys, the question is, what are we gonna do now? What are we gonna do now? What are we gonna do now? So yeah. Oh wait, gotta switch over. So the thing is, last time we built that, we also made the new battery room. Okay, first things first, let's finish up the battery room by finishing up the door. For that we need plastic and glass sheets. Dum 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 dum. Plastico glassoto. And done! New battery room completed. Next up, I would say a large station battery. Battery large. Steel, electrum, silicon, stellite. We don't have any electrum anymore. Right. So, okay. Do we need to cook? No, we don't. So, right, we could dismantle that stuff. Dun, 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 dun. Yeah, and we also like changed a little bit of stuff over here, repositioned the transformers and our power production facilities. Okay, that one is still producing, which is good. So the question is, what are we gonna do next, mostly? We could do a little bit of furnace work. Getting the electrum, for example. Mining session we could do, or just grabbing that stuff we could do. Or another alternative would be to just, like, one plan is to expand that so that we can store nitrous oxide, for example. Another thing is, Turtle! Hi-ho! Welcome back to the stream. So we're right now figuring out what we shall do next, essentially. Oh, linear rail. Oh, my goodness. Only a little bit of steel. I mean, the lorry thing itself. Lorry dock. Lorry dock. Lorry dock cargo. Lorry dock bypass. Lorry dock collector. Lorry dock hydroponics. What is a collector? The collector lorry can suck up nearby loose items when its mode is set to inward and eject stored items when its mode is set to outward. When set to suck up items, the collector lorry will automatically stop and retract when full. Pressing the activate button while the lorry arm is at its home dock will move the arm off the main rail. This allows other arms on the same rail to pass by. Lorry dock collector. Inner cell haste alloy and astraloy. Like only super alloys. What the frick? But like this thing is like, if I understand correctly, lorry is the automation. The linear articulated rail entity, or lorry, can be used to plant, harvest, and fertilize plants in plant trays. It can also grab items from chute export bin and drop them in a chute import bin. Lorry can interact with plant trays or chute bins built under a linear rail station or built under its dock. Wait, only... Huh? Okay, wait, but there's still a lorry Atmos. Atmosphere lorry can pump gas into and out of the storage canister when lowered over a passive vent. When lowered over a passive vent, the atmospheric lorry will connect with it and pump gas into it and out of the connected pipe network. Pressing the activated lorry arms at the home door, the base atmospheric logic values upon lorry's internal gas storage. The input blah 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 blah. Cargo. Ah, okay. So I still don't. Oh wait, lorry. Oh wait, that's. So that's not a lot. So the question is, what is the difference between lorry dock and lorry cargo? Lorry, the cargo lorry can take things out and put things into slots on devices. The dial on the front panel indicates which slot on the device to interact with. The slot variable of the item in the target slot can be read using the proxy slot index. Pressing the activate button while the lorry arm is at its home dock will move the arm of the main rail. This allows the other arms on the same rail to pass by. Initial Hestro and Astraloy. And that, like, really, that sounds like the ultimate automation for this game. Okay, engine. Large. Okay, so, as said, the question is what we're gonna do today. Turtle, what opinions do you have? So, like, as mentioned, there is the option of expanding our atmospherics in that direction and or in that direction. That direction would allow us a storage for nitrous oxide, which is tricky because at room temperature, depending on the pressure, it's either gaseous or liquid. And in that direction, just so we have a little bit more space to work with. So that's just a general useful thing when we want to do more atmospheric stuff. The other option is get more various alloys. Most importantly right now is electrum. We don't have any electrum left. The other option would be working on deep ore miner processing, stuff like that. Another option would be working on power. We could, for example, automate coal power production using an IC. I mean, we can't put an IC there, I guess for that an IC housing is required. But generally speaking, that's also an option. And, well, or generally expanding the power production capabilities using normal, using the wind turbines themselves. That's also an option. Another thing we could do is working towards rockets! Yes, we could do that. Or another thing that's also very utilitarian, which is working on main storage. Main storage is a room, as already mentioned, within the mountain that houses a lot of SDB silos. So, yeah. I mean, we could do the SDB silos also outside, but I kind of want to put them inside just because we can. Hold on a second. Okay. So yeah, that's also something we could do. Working on main storage. I mean, like to have a good amount of materials in storage, so I guess improve the deep ore and energy, and then see what's most useful. Okay. Turtle has spoken! We're gonna work on deep ore production facility and stuff. So, what does this entail? I guess that's a very important question that we have to ask. So there are, like, there is mostly one decision that has to be made that I'm unsure about yet. The thing is, deep ore apparently does not produce any ice, only ores, including coal. Right now we do have the and the problem is we need to centrifuge our the dirty ore that gets produced by this little guy here. We have to process the dirty ore. Right now we're doing that using centrifuges. So if I remember correctly, then one deep ore miner can fully provide, like, 2 deep ore miners can fulfill, I think, 3 centrifuges. Either 3 or 5 centrifuges, something around that. But that's like the energy, the electric centrifuge. That is. Another option is to use the centrifuge with how's it called? The combustion centrifuge. We've already built one, we can use it. Here, combustion centrifuge. The problem is, combustion centrifuge, first of all, require a little bit more control on what they do. And they require fuel and have exhaust gas. The fuel doesn't fully get burned, so that means we have to filter the exhaust. It apparently doesn't use much fuel, but it still uses fuel, and the entire process needs to be automated. However, one centrifuge, electric centrifuge, requires a lot of power, which is troublesome. Combustion centrifuge doesn't require much power, but it requires fuel. The thing is, it's a lot faster to process stuff. So, if Reddit is to believe, then it can produce... it can handle like 4 centrifuges. One combustion centrifuge apparently... Oh, wait, not centrifuge. One combustion centrifuge can apparently handle 4 deep ore miners. Come on, I'm now a normal YouTube in the hopes that that thing is not that buggy anymore. Okay, we gotta bake again a little bit. So yeah. So yeah, and so the question is, shall we use electric centrifuges or shall we use the combustion centrifuges? Because depending on that, we then have to build the facility. I mean, we definitely need a sorting facility anyway. But still. Either combustion centrifuge or electric centrifuge. What shall we do? Like the oh right, another problem with the combustion centrifuge is, like, that was where the point began, is that combustion centrifuge requires fuel, and fuel requires volatiles and oxides. Oxides we can get from the air, like oxygen, but volatiles we have to mine. That's a must. We have to mine the oxides. The volatiles. We have to mine the volatiles. Well, or get them through other means, like rockets. But we don't get any volatiles through the deep ore miner. So that means if we use combustion centrifuge, we have to ensure that we always have enough volatiles. The thing is, getting volatiles is rather easy. So in long retrospect, we could say, not that big of a deal, essentially, as sooner or later we will get rockets with which we get the ice anyway. Until then, one mining belt of volatiles probably is enough to power the combustion centrifuges that we will build. So yeah, how we gonna go? Do we want to go with combustion centrifuge or do we want to go with the other stuff? And then also the question is, we're gonna place that. We need besides the combustion centrifuge, we also need we need to automate it. I don't know if a combustion centrifuge has where the fuck is my... There it is. I don't know if a combustion centrifuge has an IC slot. Yes, it does have an IC slot. Oh my goodness. Thank goodness. Look at it. Oh, the maker of that game. Thank you, Rocketwerks. Thank you for putting an IC slot there. So yeah, we could use an IC slot for that and control that. And the outputs of that then have to be filtered using a bunch of filters, then through arc furnace and then into whatever. So we have to automate the arc furnace as well. And then into stackers, and then from the stackers into the vending machine. That would work just fine. Should you not have mainly combustion, but have some electric centrifuge just as a backup? Well, of course. But, like, I want to focus on now... I guess I would say for now we're gonna plan with 4 deep ore miners, okay? I know we don't have enough power yet, but once we have those, we have the coal, and then we can automate the coal energy production, and then that's not a problem anymore. So, the main question is, the deep ore, my plan is to, for now, focus on getting 4 deep ore miners up and running. Why 4? Because that works with there. It doesn't matter if we're gonna go electrical centrifuge or combustion centrifuge. If we go with combustion, we only need 1, and if we go with electrical, well, we need, I guess, we need 6 electric centrifuges to get that done. So, yeah, there's that. What shall we do? But to be honest, I've always made stuff using the... I've so far always used the electrical centrifuge. Let's go with the combustion centrifuge. Oh, come on! YouTube! Or Chrome! Who the fuck is causing the problems? Shut the fuck up. Leave it running, please. It's not that hard. My goodness. Okay. So I want I want 4 deep miners. So let's build them. Okay, they need electrum. So we have to first get a little bit of electrum. Well, if we want to go with 4 deep ore miners for now, that is. Yeah. Let's get the electrum, and then we can go from there. So for now, let's make sure that everything is charged. It's just for good measure. Ah, right, I need another... I should create a new large battery. Like, I always want 1 large battery in here so it can be charged up, so that there's always a full large battery. But the large battery from that arc welder is now in the area power controller of the lights and door of the battery room. So... yeah, we're gonna make a new battery, a large battery. We can't do well, we could do a nuclear one, which is even larger in regards of capacity. Steel, inner cell, astraloy. But we're gonna go with a normal large one for now. Just needs a little bit of steel. So, next up is backpack. Backpack switch, and I need the big boy. And then this thing goes into the backpack. Big boy needs power. Oh wait! Shit! I forgot that! I forgot the EVA suit!
Oxygen critical. Pressure critical. Temperature critical.
My goodness, I forgot the EVA suit, guys.
Low pressure. Pressure critical.
I just wanted to kill myself, I guess. I thought this would happen at some point. Like, I'm always forgetting to close the helmet before I start the airlock cycle. I mean, that's fine, but like, forgetting to completely dress up is hilarious. Oh no, I got that thimble again and it's doing, oh god. Oh, I forgot another thing. Lenses. First of all, power for the lenses. Power for the lenses! And I forgot to change the chip. We want that chip instead. Okay. I mean, our lenses, I guess, are fine. So we need silver and gold. I mean, there is a bunch of gold below our base, but I'm not gonna go with that yet. So there is a little bit of gold. But I just want a bigger chunk of gold. Oh, I stepped into a hole. There's a little cobalt. Shouldn't around here be like... I made one big mining trip. Ah, wait, no, I got a lot of iron, right? And didn't focus on gold. But I think I got at some point a little bit of gold. So here we got a little bit of silver and here we got a little bit of gold. Gonna do the usual again. Just digging as if there is nothing else we have to care about. Doesn't want to give us that gold, huh? Can't get it. Can't get it whatsoever. Volatiles, iron. I mean, we get a lot of iron of the through the dope ore mine. It's just that like stuff like gold and silver is stuff we don't get that much from the deep ore miner. That's a lot of silver here, but I need more gold. Ah, over there's a little bit of gold. Okay, let's dig towards there. Gold, 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 gold. Give me that gold. Gold, 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 gold. Look at me eating up all of that gold. Nom 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 nom. There you go. Ah, over there is some more, but that's for the next mining trip. We have enough gold now. Got a lot of silicon. Silicium. Got a lot of silicon. We need more silver now. Okay. And there's a bunch of silver around us, so not that big of an issue. Oh no! Nah. I'm gonna reload. I don't care. 2 minutes ago. Don't need a light. Got the lenses after all. So now I need a little bit of silver. A little bit more silver to be precise. Oh wait, that's silicon, that's not silver. Damn it. Cobalt. I need silver. Where do I get silver? That's why I got so much silicon, because I messed up there in that regard. So much nickel. So the base is over in that direction. Copper, silicon. That's a little bit of lead down there. Silicon. AU, I think, or is silver. FE is ferrite. That's iron. Ne, nickel. O2, oxygen. Fe, Ne, Se, C, a little carbon. Gold there. I'm gonna check where is our base. Base is over there, okay. cobalt, gold. Gold! A lot of gold close to base. AG. AU is gold. Okay, AG is silver. But it's also white. And that's why I... yeah. Missed it. Compared to... there's a lot of gold close to base. Holy shit. That's why I mistook it probably for... silicon. Because silicon is also white. Also, the question is, in which direction do we want to expand, like put down the other deep ore miners? But I think that is already a good arrangement that we have. Like, just expand into that direction. I mean, there's a little mountain in the way, but who cares? We're gonna strip down the mountain then, I guess. But that should work fine for us, I guess. So, yeah, I think we're gonna expand the deep ore miners in that direction, which is essentially kind of parallel to the atmospherics over there, just with a little spacing in between, which is okay. And the landing pad can be placed in between, which is okay. And it does have like one block spare space between the wind turbines and the deep ore miners, which is also good. And the wind park, if we want to expand it, we can go in that direction as we did, or we can also add another row over there, I guess. Overall, I think that's okay. Now then, let's... I need to drink some. Okay, but it's 36%, so that's fine. So we are now here, and what we want to do is we want to create a little bit of electrum. The problem is electrum is a little bit nitpicky in regards of the pressure, only 2.4 megapascals, but at least it's very, very easy in regards of heat. So, oh shit. Okay, so that is, I don't know, output. That's the input. Okay. So we have pumped a little bit of stuff in. That is now cooling down. Let's click on that. So we increase the heat and the pressure. Next up is, I'm gonna build that. So gold and silver in a 1-to-1 ratio. So 1 stack gold. 1 stack silver. 1 stack gold. 1 stack silver. 1 stack gold. 1 stack silver. 1 stack gold. And 1 stack silver. Pressure is too high, right? Yeah, pressure is too high. Also, temperature is too low. Wow. Okay. Interesting. So that is good. So next up is we have to... Are you kidding me? Now? Really? Okay. So we want to increase our temperature and decrease the pressure. So for that, let's fully dump out all we got in here. What does the tablet say? .15 megapascals is doable. I mean, the thing is that we don't have any filters on, but generally speaking, that is totally doable. How much? What's the temperature? 243 degrees Celsius. That's okay. Okay. Yeah, I guess that's enough. So now we're gonna increase that here a little bit, with which we increase temperature and pressure a little bit. 800 kilopascals to 2.4. Wait, what? 800 kilopascals? Damn it. That's a problem. 800 kilopascals is a problem. Oh shit, are we out of mixture? We are probably out of mixture, aren't we? Yes, we are. Yeah, at this temperatures, we are simply -173. Yeah, it's really difficult to heat up that stuff. We can't do that. My goodness. So let's recharge.
Hydration critical.
Yeah. I'm already inside. I'm gonna fix it any moment, so shut up and leave me alone. Yeah, EVA suit also needs a battery soon. Okay. Now, since we have drank something, let's also eat something. Oh, come on. Then let's switch up these the sensors chip. Oh. Okay. All right, there's still this heavy cable going. We can flip that around again. Let's do that pretty quickly. So, that consists of multiple things, I guess. First of all, that. And then we're gonna put that down again. Then we gotta cut this wire a little bit. I mean, it's already connected up to over here, and we have a connection over there, so we don't need... Ah, okay. Can't cut it in that regard. Bummer. And I need a wire cutter. And I can place it across like that. So next up is wiring up that. I want to use this wire instead of this wire, because that wire is a little bit more hidden and seems a little bit better overall. Like, I like its positioning more. So let's turn that on, put that guy in, and close it up. And we are back to how it should have been all along. Now I want to move this guy from here to over there again. Or up there, I'm unsure yet. I guess down here, because I can route it around here. So then we have this space available again. We can then also change a little bit of how this cable routing works here, and then yeah, we can go from there. But to successfully do that, let's do the wires for that. Ah, thank goodness that works. I was worried because that we go. I knew that we cannot make an output in that direction, but I didn't know if having an output there would count as like across it, and that would cause a problem. But as you can see, doesn't cause a problem, which is phenomenally good. So now we. Oh wait, that's the correct wire. Fuck. That's the incorrect wire. Is it now removed? I guess it's now removed. And that one is still there. Good. Okay, that's how I wanted it to be. Let's turn on the glasses so that we can see what's going on here. Yeah, we can. There is the there is a small little cable conflict. I'm aware of that one, but we can fake it a little bit. Wait, actually, there we go. We don't need this connection anymore after all. Okay, so this guy should now be connected up with the central heavy cable backbone. That means what's now left is create a connection point over there, and then we can move this guy over. And we have back some light. Now let's put that battery back in and shut it. Now gotta cut a bunch of cables like that. And these heavy cables here. That thing is connected to the normal heavy cable backbone. Yes, okay. Good. So now we have here a little bit of an empty area again. A little bit of storage. Or whatever we want to place there. So I also quickly wanted to get over to our atmospherics area. So nothing is burst, which is good. Now I'm gonna turn on our filtration units. And gonna turn on our mixer. I'm gonna let it run a little bit. We're now processing that stuff, which is good. Only 4 moles? Okay. Oh shit, look at that. That's 700 nothing outside essentially. Gotta leave that now. So, a little bit of house mix. Okay. So, got that now. Now then, let's go outside and make hopefully make the desired stuff. The desired electrum. Gotta put on EVA suit for that. Gotta switch up the batteries. And gotta go outside. Soon gonna make a short break to get something to drink. IRL, that is. Okay, hello there, how's it going, my friends? And that's it. That's what we wanted. So now we can also try to do the silicon. Since we got a little bit of that. And I'm also intend to do a little bit of the... I also intend to do the gold stack there. Converting it to normal gold, as we also probably desire stuff like that. Always love it if the stuff floats around, essentially. It's always fun to watch. And a little bit of gold. What does, by the way, the pressure in here say? Oh god, okay, we moved a lot of unnecessary stuff in here, which is a little bit sad, to be honest. But okay. So not really something that we can change. Wait. Oh shit, that was the wrong one. I wanted to god damn it. I wanted to decrease the pressure, not increase it. God damn it. Oh, come on. Why did you throw up? What the fuck? I didn't target throwing up. I targeted throwing down. Like, no, wait, throwing straight.
As we grow,
I'm gonna let that
grows with us. The
snake grows and wiggles.
and its head is
Is big and rare.
one-eyed white hole
Love that one.
separating from the rump and swimming through the cracker soup. And through suction they
Polarize.
for the fighting game event. And needles and pieces and string embroider the words in your face.
Got a little bit of pollutants in the air, which is not nice. But oh wait, that's from the okay. That's just simply from the welding we did, I assume. Pressure is looking good. Yeah. Pressure's looking pretty well. I have no clue where the nitrous oxide comes from, to be honest, but okay. $750 moles. 189. 750. 140. And 2.21 kmol. Yeah. So those are some solid numbers, I would say. I'm pretty happy about those, I must say. I do like those numbers. So I'm just gonna go out, like I just wanted to ensure that pressure-wise everything is fine. And now I'm gonna head over to there. Because I want to turn off that guy. If there is nothing else for it to pump. Gonna get rid of those little bit of this little pressure that is in there. Emptying it out, and I'm gonna turn it off. I mean, it requires a bunch of power, so definitely want to turn it off. Yeah. Seven, 6, 5, 4, 3, 2, 1. Oh, come on. Dot numbers? Seriously? Comma now? Fractions? Oh my goodness. Finally, none. So, with that, we got a few requirements solved, you could say. Now that we have a bunch of new Electrum, I don't need an auto miner. God damn it. Wrong machine, I guess. Is it you? Who is the deep miner? Yes. Steel, Electrum, Inva. Electrum? Steel. Ah, fuck. Not again. Inva. It needs more steel. Holy shit, it needs 50 grams steels for one deep miner. And a little bit Constantan. Constantan we can get. Constantan was over here. And we got a little bit of steel over here. Oh. We're slowly out of steel, it seems. There's something inside. No, it's not. Okay. Yeah, we can do two steep. We can do 2 deep miners, but then we're out of steel. Interesting. Gonna lie, I did not anticipate that. Gonna put that 1 single gram also in there because what the fuck. Little gold here, little silver, but yeah, no steel. Okie dokie. Let's eat and drink. And I will also do the same thing RL. And we're just waiting for the deep miners to be built right now, so yeah. After that, we're gonna have to switch over to chutes and sawdust, by the way. But yeah, we'll be right back, getting something to drink. Okay, I'm back again, guys. So, hold on. I want more storage. I want the hardsuit backpack. No, wait. Wait. There is backpack and jetpack. Backpack. 12 slots. I don't know what that is about. Well, we can put in a program chip, interesting, and we can put in more filters. Helmet, what's that one about? That one is just like they are more endurable, but okay. But I mean, that one has the hard suit has a programmable chip slot, which is interesting. Okay. But okay, jetpack has none slots. It does have 14 plus 1 propellant slot. And the hardsuit backpack, however, has only 12 slots. So why should I do the hardsuit backpack when I can do the jetpack instead and have more slots? I don't get it. I'm gonna do that one, but I'm still gonna do that one because more inventory. I mean, we have 10 and that guy has 15. Oh, wait, 14. Okay, it has 4 more slots. Okay. Oh, wait, also -1. So we have 9 slots and that one has 14 slots. So yeah, that's a good increase on available slots, I would say. Or maybe there is another one? No. And backpack? No. Mining backpack, hardsuit backpack, and hard mining backpack. Okay. So, yeah. Hardsuit jetpack. Steel, Vespeloid, Stellite, and Asteroid. I mean, we got all of that, so yeah. Hardsuit jetpack. Steel, Vespeloid. I mean, we still have enough steel for that. Yep. Vespeloid, Astroloid. Vespeloid and Haste Alloy, right? No, Vespeloid, Stellite Astroloid. Stellite and Steel. Steel and Stellite. Haste Alloy. Stellite. Yeah, I'm on it. Yeah, 1 and 5 more slots. 1 new row. That's an increase of over 50%, so yeah, that's really good. Okay, jetpack goes in there. Okay, so we are done with that. Now we can put those 2 guys in here. Then we're gonna grab also a bunch of frames, as we need those, and we need iron sheets. And we also need electronic parts and steel sheets. Deep miner. 12 steel sheets each. So we have enough. Cable coils and 4 electronic parts. So that means we need 8 electronic parts. Electronic parts. Iron, gold, and copper. Gold. Iron. Copper. 8. And over here we're gonna make a bunch of chutes. And there we go. Oh. Okay. That's not many chutes, but it's efficient. Okay, first things first, let's dig up that mountain. Can I crowbar? Whee! Oh, that's a little bit too far. I have no clue where that stuff landed. Okay, I yeeted that thing away. So what I now need is the heavy drill. Not the pneumatic one, but the heavy drill. Because I need to get rid of a mountain. Well, that's not really a mountain, that's just a hill. But I need to get rid of it anyway. It's ta-da, and I need to get rid of it. So here we are. So if we go down, the more we have to get rid of as it becomes wider. Gotta turn on the light now. So I want to do one more dig. One more down. Okay, here we go. Hey, come on. There we go. Now then. Was briefly a little bit confused, but now I'm not anymore. So, and now I'm gonna dismantle, like, get rid of this guy here. So I can place it over there. For planning purposes, mostly. Okay. Good. And let's put... Ah, forgot about that silicon. Whatever. And now we need those sheets. And weld a little bit. Perfect. So we now have here 1, 2, 3, 4 of those. So another question that we have to decide upon is, do we want to do first arc furnace and then sorting, or do we want to do first sorting and then arc furnace? But yeah, due to space considerations, I would say we gonna add the combustion furnace over here. So then we can put on another level here, or maybe here already, the arc furnaces and sorter stack essentially. And we're gonna grab the stuff from here, which just transfer to over there essentially. The thing is, I usually want to like make it go up a little bit over and then down, and up there connect up all the different ore miners so that we can walk here a little bit. If you get what I mean. So, yeah. Considering here's the output. And then we can do here sorters and stuff. And we connect those up here via chutes to all the way over here. Go up, over, down, and into there. You'll see in a moment. Exactly like that. We need a lot of chutes. I'm well aware, but I hope you get the idea. Also, I want a window here so that we can look a little bit if there is something waiting essentially to be processed. So yeah. Another thing is we might want to put maybe we also gonna put a stacker there, to be honest. A stacker might be useful. The problem is I don't know about the limitations that you have to consider when working with a stacker. Okay, yeah. That's the consideration. I would have placed it like that, but you can see that doesn't work. I have to put it over there. Also, I should turn around the guy, so the interface here is the same as the interface of that guy, I guess. So that means between stacker and this guy, we have to put down a chute. And that one I would like to also make a window. Like at entrances of machines and stuff, I really do like to have a window. Because then I can see if there's something waiting to be put inside. Essentially. So, okay, but I'm gonna put the stacker back, as it's still used over here after all. I'm unsure about where I'm gonna put the T sections. I mean, right now they are on this level here. I don't know if we're gonna put them one level down, or we're instead gonna put the entire this bridge here a little bit up, essentially. That's something I have to consider. Or maybe this bridge instead. It fully depends on how they will look fully built. I mean, okay, what does it mean when? We can do that right now. And screwdriver? No? Cable. Oh, cable coil. Cable coil and screwdriver. Okay. Survive eating only potatoes for 30 days. Cool. Cool. And screwdriver with electronics parts. Ka-ching. Ka-chong. So I think it's a good height for the chutes. That means we gotta put the bridge one step further up.
Power low.
Like that. And that. Okay. I think that's a good, somewhat good arrangement we got here. Got a little bit of space to walk through. So we can do that. And we have here a little space to make the sorting facility. I mean, there are only a few resources that we have to care about. And that are those. I mean, okay, that's a few many. How many are they? Okay, it's 10. 10 things. 10 things that we have to filter. That's tricky getting it in that space, I think. We will see. Doable, but close. Will be a close call, I guess. Okay. So, what does this guy need for construction? Welding torch and steel sheets. We can do that. Cable coil. Oh, and already done. Okay. So, this is the ominous centrifuge. I don't know if I'm gonna put down an additional frames. Might be useful. Could be. Doesn't have to. Oh, look at that. My goodness. So yeah, that's the combustion centrifuge. And then stuff will be outputted there. And then it goes through a sorter. And that will split up the stuff then. The question still remains, shall we do like one arc furnace for everything? Or one arc furnace per resource? I mean, there are some resources that don't need an arc furnace. But they should be able to simply pass through the stuff. But okay. Generally speaking, I would say that's good. I mean, we need a lot of iron. We need a shit ton of iron to get the fuel from over here to here. We need a shit ton of iron for that. I can already see that. And yeah, there are also other things. But yeah, this is really a little bit too small of space. I really would like to have frames over here as well. And since we now have that space, I also want to center the machine here. Well, okay, I mean, we could argue the chute here is already centered, but the exit chute is not centered. So it fully depends on how we want to view it. But I think, yeah, I want to put it one step further inside. Angle grinder. So yeah, instead of here, I want to put it here. Window and corner. Window. And as decided, one step further up. Is here we're gonna do the no wait. We're gonna do the crossing on that level below, so it was already right. Okay, never mind then. Like that. So with that we can just easily follow how I planned out the things. That's why it looks that weird. So let's go back inside and craft the necessary sorters, and oh. And if we have some more iron, then I'm gonna make more chutes, as we need tons of chutes, and then we will see how it will go. But before that, we're gonna drink a little bit. Fill up the bottle. Turn off the light. Swap the battery. Various things to do. That thing is still turned on. Those things as well. Not that good. I mean, okay, that guy still has a bunch of iron. Wait, hold on. Who does have the sorter? Sort. What's the difference between logic sorter and sorter? Contains an internal memory which is accessed to check whether something should be sorted. When an item is in input slot, the stack is checked, and if result is true, then the thing is moved to the export to slot. Otherwise, it's moved to the export slot. The mode is used in how the stack is accessed. By default, the mode is all, so every instruction in the stack would need to return true. Internal memory. Okay, that's cool. That's really cool. Sort. No? Sort? Sort. Logic sorter, also kit sorter? Yes, kit sorter. Okay. Gold and copper. Gold. Only 2 grams of copper. Seems like we are out of copper. So we are out of steel and we are out of copper, it seems. Interesting, problematic. Well then, we gotta head out mining. So we need iron and we need copper. That should be pretty easy. Okay. Thankfully, there's also right away a little bit of iron. We need 3 stacks of iron, then we can make 200 copper, and that will be hopefully enough for the first bunch of stuff. Okay. I need more iron. There we go. Yeah, shit. I've fallen all the way down. Aha! I remembered how I can get up here, back up here. Inventory full, damn it. Come on. Yeah, there we go. And done. Okay. I forgot to fill up the... whatever. Let's go with the gas we got. 2, 1... First things first. Copper. Here we go. Big chunk of copper. Got it. Well then, let's make a little bit of steel. And 1 stack of coal. Yeah, we probably need more heat. Yeah. Yeah, we do. There are a lot of gases now from the copper inside. I get it. So volatiles. Let's go with that. Ah, I should have dumped the pressure before I've put in the volatiles. Let's grab the tablet. I'm always turning the wrong one. Gonna do it slowly because I want the pipes in between to also breathe a little bit. I shall make a bunch of ICs for that. So it can be vary of that shit. I will have to get... I have to dump everything out of there and then heat it up again, so it's not a biggie. I hope. So my plan right now is let's create 2 ICs or so. Gold, steel, electrum, solder. Solder. Electrum. And steel. Got a little bit of steel. So we gotta make, I think, 2 ICs for now. There we go.
Hunger caution.
Oh, come on. Then let's eat something. Lot of potato. Okay, so let's do some IC programming, you guys. So it's like I have two main questions in regards of the IC programming. The first one is when we are accessing, like, we can't, like, devices, how do they work essentially? None. Macro. Any valid binary number passed together as a binary. Okay. Oh, any valid hex characters together as hex value. Okay. Like, we can, like, loads device logic type to register by housing index value. To register by housing index value. The question is housing index value. What are the possible housing index values? That's an important question right now. The question mark. Is there something on ICs? No. Stationeers device ID. Device direct access versus named hash. We will limit just to D0 to 6 physical device ports. HD device set by the screwdriver. Therefore, you can address machines by type and name hash and receive a batch. Later found if you know you only have one of them, you can just maxmin the reference ID of all matches and save it to register and use for device direct reads writes. SDLD, etc. Now I'm procrastinating when to use each. Procrastinating. Device port based scripts are nice because you can reuse the same script in different housing with different devices. Device port based scripts are rubbish when you want to display data. Every sign requires a device. You can have 6 total. To my greenhouse air system, that's I'm just reading something up on Reddit right now. Well, for now I moved the grow light stuff out of this IC, losing 2 devices and again 2 ports for LED screens. Other things like my generator control script has about 10 devices it wants to talk to, including 3 screens. Better using a mix of the 0 to 6 registers, name hashes and batch loads and direct reference ID. Device ports are simple, quick and easy. The only reason not to use them when you can is you don't need this in your program. The only reason not to use them when you can is you don't need this in your program. Batches are better when you need to address a lot of machines at once. Name hashes are great for pairing devices together, like for sending data to a display. They are the least code efficient though, since you need to define the device and the name. Device IDs are basically ports, but have the required extra step of knowing the device ID beforehand, which requires a configuration tablet computer. They are also not as portable as ports, since device IDs are super specific and hard to change than taking a screwdriver to a pin. This don't allow slot access. They also don't allow slot access. Very interesting. There's no load set device slot command, which can be annoying depending on what you want you're programmed to do. I've used all 3 sets of addresses in some of my room controllers because I ran out of pins but wanted more functionality. And Autolight store back to be batch commanded. Okay. SD stores register value to logic type on device by direct ID reference. Branch. Relative branch. Comparison. Cosine define. Creates a label that will be placed throughout the program with the provided value. Division. Exponent. Floor get. Using the provided device, attempts to read the stack value at the provided address and places it in the register. Seeks directly for the provided device ID. Attempts to read the stack value at the provided address and places it in the register. HCFs. Halt and catch fire. I see. Jump. Loads device logic type to register by housing index value. Loads logic type from all output network devices with provided type hash. Wait, loads logic type from all output network devices with provided type hash and using the provided batch mode. Average, sum, minimum, maximum. Can use either the word or the number. LBN loads logic type from all output network devices with provided type and name hashes using the provided batch mode. Loads magic slot type from slot index from all output network devices which provide the type and name hashes using the provided batch mode. Okay. Loads device logic type to register. Let's device logic type to register by direct ID reference. Let's loads reagent of device's reagent mode where a hash of the reagent type to check for. Loads slot logic slot type on device to register. Max min mod move register. Register equals provided number or register value. No, not or peak. Register value top of the stack. Stores the provided value at the provided address in the stack. At the provided value? Wild. Pop, push, put. Using the provided attempts to write the provided value to the stack at the provided address. Wait, what? Provided. Using the provided device, attempts to write the provided value to the stack at the provided address. I'm confused. Wait, why is the pause not working? Okay, so round it to nearest integer. Source register value. Okay. Now, okay, I think I get it. Zap. SB. Okay. Register equals 1 if device is not set. Register equals 1 if device is set. Otherwise 0. If it is non-zero, otherwise sequence. Select something. Sign performs a bitwise arithmetic. Sleeps less. Performs bitwise logical left shift. Performs a bitwise logical right shift. Stores register value to device stored in the slot. Zap. 10 trunk. XOR. Yield. Okay. Throw light control. So now I'm gonna check something. That is 0 and that is 1. My question is, can that thing reference itself somehow? Stationeers, filter, IC, slot. Chips for built-in IC for filtration units. You don't turn them off, you have to stand by. Okay, so we can also shut down the filtration units, but we're gonna put them on standby and not turning them off. Important difference, it seems. The question is like, how do I reference the internal filtration? Okay, hold on. Stationeers, IC10, self device. Integrated circuit, IC10. Or directly into the program slot of certain devices, e.g. atmospherics. Okay, I have 8 channels which can have data loaded from store to via device connect. Oh wait, hold on, there's a crate. Okay. Holy shit. There are various things that, what the fuck? Okay. IO to device registers, IO to device registers, batch IO to device registers, sample, special registers, special registers. There are 2 more registers, one called our return address and one is stack pointer. Okay. Classic stuff. Stack memory, comments, device pods, that's what I'm interested in. Labels, constants, numeric values, indirect referencing. Addressing a register by using another register as a pointer, adding or... Okay. Adding an additional R in front of the register turns on this behavior. Indirect dynamic changing logic type when interacting with device registers. Network referencing channels. That's like network referencing in channels, which is wild. All logic maps have bitwise behavior. The available gates are okay. But yeah, like network referencing in channels, that's crazy. Debugging advices. Learning IC10. Seems like a cheat sheet. Instructions. Utility. Mathematical stack. Slot logic. Bitwise comparison. Branching. Conditional functions. Cheat sheet. Device variables. Slot variables. Examples. Yeah, okay. Harvey automation. Script uses the batch instructions to control all Harveys on the network, but only one Harvey and one tray will be the master and have their values read. The rest of the Harveys will repeat exactly what this unit does. Some problems with this doesn't that different types of crops mature at different speeds. Okay. Push and pop, return address, my calling multiple. Okay, whatever. I'm interested in device ports. ICs can interact with up to 6 other devices via D0, and D5, as well as the device it's attached to via DB to change or set it. Okay, that was the hint. DB, that's what I was interested in. Okay, so we can do various things, it seems. What the fuck? Okay, so we can do a handle filtration. And then we can directly make use of, like, for example, this indirect referencing. Adding an additional in front of the register turns this behavior. The value stored in the register being used is the pointer must be between 0 and 50. This will then point to the register from R0 to R15. Higher or lower values will cause an error. Okay, so what that means for us, like, okay, the other problem is like device. I mean, can I move a device into a register? So I can now, for example, do this. Also, this also works with devices. Okay, this is good. Move R0 to stores the value 2 in R0, and then I can say device register 0, and it will read register 0 and whatever that is. So it goes back, like it goes from right to left. So what I was saying is that we can say is the following. We can do loop, and I don't know, is there like call, or how do we do this thing with the stack pointer? What is the calling convention essentially? Stack memory. As mentioned, SP can be both written and read from any time when reading peek or pop. Must be between inclusive. That was logic chips. This means that if you have a logic chip in a stack, but that this does not carry over any other logic chip. There was like a return RT or so. Red. RT. Oh wait, that was like something in regards of special register, right? Registers, special registers. RA, return address, and one called SP. The RA is used by certain jump and branching instructions, those ending with AL, to remember which line of script it should return to. The SP tracks the next index with the stack. So we gotta check out the jump AL instructions. Shall jump execution to line A and store next line number in RA. Okay. So if I say shell filtration, for example, that would work. And then I can, for example, say move something into R0. And what I'm gonna move into R0 is what? D0. Wait, no, DB. Yeah. And then I can do, say, R1 into, then I do D0 gel filtration. And then I can say R1 into D1. And then I can then jump to loop. And then we repeat it. So, within filtration, we can then say, give me some value. Let's check the filtration unit. That one has various variables that we might be interested in. Mostly pressure input. So I'm mostly interested in pressure input and pressure output 1 or output 2. That's the question. I don't know. Reading of the device's output network. Ooh, output 2 network. That's a problem. I don't know. Like, output 2, output. Okay, that's weird. Huh? There. Unfiltered. And then pipe corner output 2. Very interesting. Okay. But we now know that's output 2. So we're gonna pause. So we care about the pressure of output 2. We check the pressure of output 2. How we do that? So we load to where? We're gonna load into register 1 of device. Now the interesting thing is we gotta use DR0. The device that gets referenced by R0. Oh, wait, hold on. I gotta check, I have to read upon that again. Into the indirect referencing. Stores the value 2 in R0. I don't know if that works. If I can just move dB into that. That would be really good, but I guess not, because I also can't move like doing R1 into there. That also doesn't make much sense. So either that or it's 0, 1, and 6. Something like that. But okay. And then we're gonna store, and then we wanna pressure output 2. So that value is now stored in register 1. And then we can decide what to do. We can then, for example, say then there are like various jump instructions. Oh, come on. Do I have to say jump specifically? Okay. Branch. Branch, like here, L. And store next line item in the if device is set. Relative jump. Relative jump. We don't need relative jump. We need a normal jump. What about branch? Branch to line D if A, B. Oh god. An entire. Holy shit. Branch if line C is no. We don't need epsilon there. Device D set. I mean, generally speaking, okay. Would be kinda interesting. Branch relative though. Equal. Larger or equal. That's more what I'm interested in. Branch to line C if A bigger or equal B. BGE. Okay. BGE. We're gonna jump to C if A is bigger than B. A is R1. And then we're gonna use here some, gonna call it max pressure. And the line we want to jump to is RT. RE? How was it called? The special register. RA, return address. That's where we want to jump back to. Or do we? No, that's not what we want. I mean, okay, we need a comparison. Bigger or equal. GE. I hate this search function. Oh god. GE. Compare. No? Fuck. Really? There's only branch? No, wait. The ones I want is select. Right? So, register equals 1 if blah blah blah. Here. Register equals 1 if A bigger B, otherwise 0. SGE. Select greater equal. Or however. So that means instead we're gonna go with SGE. Register 2 if Register 1 is bigger than max pressure. I'm gonna define max pressure with 10. I don't know. I mean, we need like megapascals or whatever. MPa. But whatever, we will see. Okay, so that is now stored in R2. Next up is... Wait, hold on. We want to set it... We want to set register... Devices set... RMap. No. If... Is there a less than? Yes, there is. Okay. Okay, so then we gotta use less equal. So that means if R1 is less or equal than max pressure, then R2 is 1. And 1 means you shall do your processing. Because it's not too much pressure. So that's what that means. But I'm gonna continue now. I also gotta load into... Okay, hold on. Gotta make that a little bit different. So, gotta use that there. Gotta R2 there. R1 there. Because then I can reuse... It's a little bit more. Whatever. R2. DR0. Pressure... input. Just pressure input. And we say we need a minimum amount of pressure to enable it. So that means we need greater equal. We store the value not in R... Wait, hold on. Yeah. And we store the value in R3. Get the value from R1, and we have min pressure. Define min pressure. So min pressure is the minimum input pressure that needs to be exceeded for the filtration unit to turn on. And the maximum pressure is the maximum allowed pressure in the output pipe that the thing might turn on. Next up is we need an AND instruction and a store instruction. So I hope AND works like I think it does. Performs a bitwise logical AND operation on the binary representation of two values. Each bit of the result is determined evaluating the corresponding bits of the input values. Both the bits are 1, the resulting bit is set to 1. Yeah, okay. I mean, since we in both scenarios R2 and R3 either 0 or 1, the bits match perfectly and the bitwise AND should work just fine. We store the end result in R1. We don't need the other stuff anymore. And we're gonna do R2 and R3. Also, by the way, we store here in R0. And next is we gotta store. Filtration unit has what values? There's like power, open, okay, what the fuck? Oh wait, power is read. Can be, okay, hold on. But open, if device is open, otherwise 0. I gotta come on, like the documentation on that is really bad in here. I have to check up on. I have to use the stationeers wiki, the unofficial one, to read upon that, which is quite frustrating, to be honest. IC10. No, wait. Filtration. Because they explain it at least a little bit. So, on. Powers on the filtration unit on when set to 1. Powers off when set to 0. Open, setting, lock, and mode. Okay, mode is idle or active. Open. Returns whether the filtration unit IC slot cover is open or closed. So that is what open does, apparently. Mode. Returns whether filtration is active or idle. Arrow. Filtration is flashing an arrow. Lock. Returns whether the filtration unit is locked. Doesn't tell me what locked means. The filtration is turned on. 0 for no. 1 for yes. So I would care about what a setting is, what the setting is. Variable that can be read or written depending on the device. Thanks for nothing. Really frustrating. Wait, there is a utility. There's like a helper cartridge, if I remember correctly, for stuff like that, right? Isn't there? Cartridge. Configuration. Access controller. Okay, that's security stuff. Configuration. No clue what that one does. Guide. E-reader. GPS. And well, network analyzer. A minor masterpiece. Network analyzer displays the current voltage, wattage, and cable network, as well as based on widely copied synthesis, and it's used in conjunction with or core handheld tablet. Okay, it's not a logic analyzer or whatever, which is a bummer. Let's check what the configuration one does. And I also want to check up on what the guide thingy does, to be honest. Sounds also quite interesting. Okay, what do we need? Cartridge. By the way, stream gonna last a little bit longer today, as I don't have to get up early tomorrow. I want to check up on configuration and upon guide. Okay, there is no guide. Okay. But okay, that's all. Configuration. There is nothing else. Like, that really sounds like the thing we might use. Network analyzers for power and stuff, so I don't know. Yes! That's exactly what I wanted. To be honest, that's exactly what I desired. So I can check out what this setting does. So, open is this thing here. Mode is set to 1. So that is power and on. Those two values are just simply if it's turned on or off. Setting 50. Maximum 100. Ratio 0.5. What does that mean? What does setting mean? And what is the ratio? Is this the speed it can do? Let's ask Uncle Google again. Stationeers, filtration, setting. What is the filtration device setting? Or what is filtration ratio? The minimum processing rate occurs. I don't get it. What is the filtration? What is the setting? Is it like the only thing I could think of is how it's... But I mean, no, it doesn't. Okay, no. I don't know. Also, I don't know what lock is. Is lock like locking the... being able to open and close that thing? Control it, or what is it? Pressure output. Ah, wait, that's the pressure output. Never mind then. But yeah, still, what is the fucking ratio? I'm confused by it. What that does and mean. But okay, let's continue here. So, anyway, we store into mode, I think it was called. Filtration. Mode, read write, yeah. Not into on, because on will turn off the entire thing, including the IC, So instead we're gonna go with mode. Oh wait, the device, DR0. Logic type, mode. Mode? Okay. And R1. And then we say jump RA. Jump back to return address. Okay, and then we're gonna say, and then we additionally do a jump if not set. Jump AL. Next line of the, okay, here. Jump execution to line A and store next line number. Okay, we don't need that. We just need to jump to line if device is not set. BRD, no wait, relative jump. We need a normal jump. So we need probably BDNS. BDNS. Branch to line A if device isn't set. BDNS. Okay. That's what we're gonna do up here. BDNS. Device in register 0. And we jump to return address. Confirm. So then we're gonna put this. Okay, also, other question is, what is the pressure value exactly? I need the atmospherics cartridge for that. To know, because I need to know how much pressure is in the tank, and then I can compare the value of the tank pressure with the value that I receive. And then I can compare the tank pressure with the value I get from the configuration tablet. So, what pressure do we have? We have 947 kilopascal. 947. And what do we get here as pressure? 947. So that means the reading is in kilopascal and the temperature is in Kelvin, I assume. .353, yeah, probably Kelvin. Yeah, Kelvin. Pressure output is 947. So that is in kilopascal. So this consideration is important as it decides on what values we're gonna put in. So we're gonna go with a max pressure of 45 megapascal. So 45 kilopascals. And the minimum input pressure that I want the stuff to have for the filtration to happen is I want at least 1 kilopascal. Or well, 0.1? Let's go with that. We're gonna, like, if it's empty, okay. Like, this is 1 pascal. Min pressure is 1 pascal. If it's below that, fuck it. Min pressure is 0.001. Confirm. Export. Gonna grab that. Okay. Incorrect variable at line 7. Yeah, okay, so that doesn't work. So 6, 0 and 1, I hope. Confirm. Export. Oh, come on. And 15. Why? What's the concrete problem? Error unknown. Unknown at line 15. Okay. Unknown? DR0 6 -1. I mean, what is B? Error out of device bounds at line 15. Okay, but like 6 is okay. 7? Unknown. Is it 2? Unknown at line 15. Just tells me it's unknown. Wait, hold on. Just to make sure that it's not one of the other ones. Jump loop. And we go again with 6. Yeah. BDNS. A BDNS. That's how it should be. We have gel. Also, there's a missing gel filtration. But like still, come on. We got a gel here. What is this issue? About what is it exactly complaining? If you're gonna go with 0, I mean, nothing is connected up, but I have a check for that. Okay, 0 is working. So the main question is indirect referencing of the base. The ways. So this is a way of accessing register capacity pointer. Adding an additional R in front of the register turns on this behavior. The value stored in the register is being used as its pointer must be between 0 to 15. This will then point to the register from 0 to 15. Higher or lower values will cause an error. And then there's an example for devices. Move R0 2 stores the value 2 in R0, and then store DR0 on 1 is now the same as SD2 on 1. But what about B? What is DB? Stationeers IC10 Indirect referencing DB. Indirect referencing. R1. Seriously, what is the value that is equivalent for dB? Okay, so it's also better to insert the yield apparently, as it doesn't really do an execution per tick essentially, but faster. Indirect referencing. Okay, I have here like a GitHub page open. Maybe that one is a little bit help. Hopefully that one is a little bit helping here on how we can referencing that. So here, indirect referencing. Indirect referencing when you use the value in register to determine what other register or device to interact with. Move R0 to LR1 DR0 setting. The indirect referencing is the DR0 part. You can read it as device stored in R0, which means reads it from device 2 since R0 is 2. If you want, you can reference multiple times in the same reference, but that gets unreadable fast. So, what devices are we addressing here? Let's break it down. Blah, 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 blah. Since the maximum of devices an IC housing can connect is 6, this would break the script. This is why multi-level referencing should be used extremely sparingly. Yeah, okay, but how can I reference the base? That would be really great to know. Indirect referencing base. Base device. Stationeering. There's a website called Stationeering. Interesting. Indirect? Okay, doesn't work. Check out the guide. Yeah, I'm trying. I'm searching for indirect, but like search itself doesn't work. Okay, whatever. That doesn't work. That can't be used. It's a React app. I can see why it doesn't work. Learn basic IC programming. No. The problem is I want to reference base. Oh, come on. Station is IC10 indirect referencing base device. IC10 number of dB. I mean, that's sad that that doesn't work. That would have been very cool. If I do that, it doesn't like that, right? Yeah. Line 7. Doesn't like that. Which was to be anticipated, like what it was to be expected. And it doesn't want dB. It likes 0, it likes 1, but it doesn't like 2. And it also doesn't like 6. What if we go with 16? Just saying unknown. Okay, it doesn't tell me anything in here.
Hydration critical.
Out of device bounds. Okay. The question is, what is the device bound? 160. Let's go. Out of device bound. Let's try 20. Out of device bounds. Okay. Then let's try 17. Unknown. So 20 was 17. 19. Out of bounds. $18. Okay. So that means 17 is the highest number. But it just says unknown. And it doesn't like 2, and it doesn't like -1. 0 is also used already, and 1 is probably working. Yeah, 1 is working. So the question is, so I guess I cannot use dB, which is annoying. Stationeers. Um. DR0 dB. I see indirect reference indirect referencing dB. How do it indirect it can cause? You know what? Let's give AI a chance. ChatGPT. Let's ask it. If it can answer, great. If it cannot, well, what a shit show. So I'm playing Stationeers. I'm trying to code, and I see I want to use indirect referencing, and I want to use indirect device referencing. What number do I have to store inside an register to reference the base device DB? Let's see. Represents the base device. It's gonna loads the value of the setting value. Up. I'm asking how to go about indirect referencing, like doing move 0 0 L DR0 on or wait, setting 1, which, so like doing that, which is equivalent to SD0 setting, wait, let's do D5, which is equivalent to DR5 setting 1. Allows you to select device variables on a register device. This is particularly useful when you want to write to device to identify stored in a register. Yeah. Where's aliases? No, it can't help me. If I want to reference DB, what number do I have to store in the register? In stationeers, you need to store the device in the... So in the D, you can use the S instruction combination register that holds the device identifier. It doesn't. No. It simply doesn't help. What is DB as number? Please. Stationeers. Stationeers. DR0. IC DR0 DB. Okay, hold on. Maybe now I've... DB. Nope. Base? Nope. For the device dates. Okay, I have one more idea. Okay, so I have one more idea, and that is asking on the Discord. Is there a forum, or are there just chat rooms? It seems there are just chat rooms. Logic circuit discussion. Tutorial atmosphere, dedicated server, game balance plants, rocketry, trade and power discussion. Okay. Simple question. What number do I have to put into R0? To write the setting of DB. And then I'm gonna write the little example code, which is move R0. What? Question mark. S DR0 setting 1. Very simple question that I would like to get answered. Oh, I'll also add a yield pretty quickly. Yield. My hope is so that like there is a guy in chat, so yeah. Also gotta get rid of this here to not confuse that. I've just sent him the entire in the Discord there the entire script you got so far, and hoping that he might answer my question, because he of course just answered, well, just use SDB setting 1. I know that you can do that, but as like, I want to use indirect reference here. Referencing here. Let's grab something to drink while I'm waiting for an answer. It's not that hard. Like, what I want to do is conceptually not that hard. And now he's quiet. Can't answer my question, I guess. Ah, okay. Hovering here gives us a little bit of info. That's cool. Vegetable and I if the device D isn't set. D a 0. I mean, we can do that, which is so annoying because that means I have to make it reference itself. Filtration O2. CO2. N2. And wall. And then I can change that stuff here. I cannot you cannot reference using the bolts yourself. Interesting. What? What the fuck? I got an answer. We will try that out. No. Out of device bounds. Getting out of device bounds. Yeah. I cannot That's so stupid that you cannot reference yourself. I'm in the bolts there. That's so stupid. To be honest. I think at least it's stupid. Okay, then we're gonna reference CO2 and N2. Mode is 0. So required power is 10. Required power is 10. Why is the mode... Why does the mode exist then? I mean, well, okay. I mean, it's just about, like, okay. Like, still the filtration stuff, okay. But power like, the minimum pressure doesn't make any sense as the power... As apparently power doesn't make a difference. Hold on. I gotta answer that guy pretty quickly. Huh? Yeah, but okay, I mean, like, okay, that guy says like they mapped dB to int.max value. dB they mapped that, but int.max, the guy sent me that, but that doesn't work. Just gives me the error we've seen. The out of bounds issue. Yeah. Out of device bounds. Int max val. Gotta try a different one I find in the web. Okay, web. That's the one. What about in 64, Maxwell? Still blinking. Okay. DB can't be reached. This is unbelievably frustrating. I mean, we could now create an IC for every single one of them, or like have a bunch of duplicate code. I'm a programmer. I don't want duplicate code. What the fuck is... DBRA. Oh, wait. A loop. Wait, there is... Like, I don't need that check. LR1. DB. Pressure output. 2. SLE R2 or 1 max pressure. LR1. DR0. Pressure input. SGE R3 R1. Min pressure. And R1, R2, R3. And last but not least, SDB mode R1. Also, gonna change that to DB. And confirm. Export. And put it in here. Now we gotta adjust. So this is CO2 and N2. CO2 and N2. Mode is idle. But required power is still 10. But okay. And you are also mode idle, and mode active. Required power 10. So that doesn't change required power. Interesting. Okay. Let's also write this guy. Put that in. And we got a filtration set up for those now. Also, library, filtration, safety. Confirm. Okay, so we have a filtration safety setup now. What does this... Okay, this guy, gas mixer, doesn't have pressure information of the outside. So we would need a digital gauge there, so we can figure out what value that guy has. So that we can constantly pump stuff in as fuel, essentially. But before we do that, gonna turn that pump on. Let it fill with a little bit of fuel. So now we gotta walk back. Back, Sarak. Okay. Now let's turn on that. Oh wait, hold on. Gotta eat something as well pretty quickly. And then we're gonna go outside and make that steel that we wanted. Okay, wait, hold on. Sorter. Sorter was in here, I think. Sort? No, it was not. Damn it. Sorter. Needs copper. Okay, but we got the copper. Nope. The copper. There we go. And now we can make a few of those. We need 9. We need exactly 9. Then we also need... then we need 10 stackers, and we would like to have 10 arc furnaces. Okay, we got 5 sorters. But we need 9. And as mentioned, we need a shit ton of chutes. And the chutes are rather expensive, which is annoying. There we go. And then we need stacker. They take quite a bit of time. Ooh, out of power. Not good. I have an idea in that regard. I just realized something. Since the code is a little bit different between those, we can In this for the filtration here, instead of using mode, we can use on. Okay, that one is still reading the pressure. Very important, even though it's turned off. That was the interesting aspect here. So those are now essentially turned off. I wanna write the same code to that. That is more power efficient. A tooltip would be nice. Overwrite instructions. Are you sure you want to overwrite this script with the data you have in the computer screen? Just overwrite. Okay. So, export. So that way only those two filtration units are really running. Which is at least a little bit more power efficient, essentially. And the base has power again. So now then, let's go outside. Or not, because we wanted to produce some stuff. Yeah, we wanted to produce some stuff. Okay, we need more stackers. And chutes. We need various more things. Okay. Let's go outside. And then we can turn on the cold power generator and fill up our battery, our station battery a little bit. That should help a little bit. Gotta open up the waste canister. Okay. Hello there, Jupiter. And we of course use a logic sorter. We have to separate again a little bit. And we also have to... Oh, okay. Those guys are ready, so let's turn on that guy and open up these centrifuges. And let them dump their stuff into the thing. Okay. Now let's dismantle that guy, as we need that one for measuring some stuff. So the thing is, do we want to only have one? Like, if we get a chunk of some specific resource, do we just want to put it right through the arc furnace and then through a stacker, or first through a stacker and then through an arc furnace? But I assume there is not much difference essentially, so we could also do an arc furnace directly. It still has probably a spacing of 1 in regards of difference. It probably still needs like one slot, one chute slot. Yeah, that one is now producing a bunch of power. We gotta go inside, build some more stackers, and grab the one arc furnace that we have. That's a recycler. We are making a stacker, right? Yeah. Just that the package looks very similar. Beacon, arc furnace. There it is. That's the guy we need. Five stackers so far. Gotta recharge EVA suit battery. 7th. Soon we gotta refill our EVA suit again. Nine. And that's the 10. Arc furnace. So the question is, what resources does the deep ore miner return that we want to put through an arc furnace? So there is iron. Okay, so like there's iron, there's iron, there is copper, there's gold, there's silver, there is nickel, silicon, and I think that's it. Oh, and lead. By the way, we are doing that with the melting, with them using the arc furnace and not storing it as ores is very simple, because storing it as ingots is simply more efficient space-wise. Like ore stack is 50. Like we can store 10 times more stuff in form of ingot than in form of iron. If we want to reuse the gases that are produced by the arc furnace, well, we have to encapsulate it in a small room and then use the output of that, I guess. That's something we should consider in how we align the stuff. But okay, so iron, copper, gold, silver, silicon, nickel, lead. Which makes 7 arc furnaces. Ah, I got one stacker too much. Damn it. Not really. Oh, yeah. No, wait. No. I need one for the input.
Filter low.
Okay, we cannot stack those. Interesting. Filter low. Do we have a little bit of iron? I think it's steel. No. That one has all the iron, it seems. We don't have any iron in here or lying around, it seems. Bummer. Because of filter. So we can put a stacker in here. But the nowadays more interesting question is on how we're gonna do the arc furnace stuff. Because that was an extreme plot twist. That we shall consider that. Okay, putting everything into the other, like putting the stuff back in one row again is probably a little bit better in regards of walking, because if we put a wall down there because we want to encapsulate those, I mean, we don't have to, we can also put a wall down here so that can be outside. So, yeah. But it's probably still better to have it one step over. Let's check that first, use for the stuff over here. So like instead of having it like that, we're gonna have it like that. And that means we will have the arc furnace like that. Yeah. Then we can walk here a little bit. We cannot walk over here anymore because then that stuff is in the way, but we can walk here where we can reach those and these stackers here. Well, actually, only if we do the arrangement like that, that is, there's another way to do the arrangement. We could also instead do a setup like that. And then I gotta put that thing there. And then we go up.
Air tank low.
That stores a little bit on space in that direction, which is a little bit problematic anyway. And that almost looks like somewhat of a perfect space. And like if we put it here, it would clip a little bit. But if we put it here, perfect distance. Okay. I mean, we could put it. Oh, we could put it all the way over here. Like that. But yeah, then I don't want the arc furnace that close. Then I probably want the arc furnace a little bit further away. And okay, the arc furnace... Okay. I would not be able to place the arc furnace there as they would clip with each other. I would have to place it a little bit further away. But this changes all of it a little bit. I mean, because we could also say instead of going in that direction a step, we could go one step over here and fix some of the clipping that way. Oh, okay, yeah. Only some. We can place that still here, and then we have here the clipping. But yeah, we're definitely gonna have to put it one step over here, as we need that space over there anyway for this, for the stackers, and then the chutes along that axis, essentially. And even we might maybe even put that one step further. Then that's an additional space consumption. A lot of sorters. That have to be connected up with chutes. So, and yeah, then we have the problem connecting up this here, essentially. Then from here into stacker, and then from stacker into the vending machine. I don't know what the English word for Geizhals is, but I don't want to be a Geizhals. So let's give it the space it deserves. And this here, if we make it like that, I assume a chute would clip. Yep. Chute indeed does clip. I don't want to clip. So it would be better if we go like that. And also I will then also make those chutes windowed chutes. I mean, okay, but the problem is now it's clipping there. I don't know. But I'm a little bit scared that the same thing happens as over here, where it shows the stuff to be dropped there. So I'm gonna go with the other variant. The other variant being straight. Okay, but that means we consume a little bit more chutes. But that also means we have a little bit more buffer between what comes in and this. Which doesn't matter anyway, because that will release then one chunks at some time. And then the other one has to wait a little bit, so... That shouldn't make much of a difference. But, okay. So I guess that's the arrangement that we're gonna go with. Gonna reallocate that stuff pretty quickly. Opposite direction, please. Gonna go in that direction. Window. Corner. Perfect. Next up, wire cutter. Crowbar. No, angle grinder. And drill. There we go. Then we need a welding torch. And wires. And now we need water, food, power, air, health, and a new lung, essentially. And chutes. A lot of chutes. And we need to... and... the question is, in which orientation do we want to put the stackers in? Do we want to put them like that? Or like that? I would say let's put it like that. Use that, and then we'll have that over there, and then we'll go from here. The buttons of those are also on that side. So, yeah, let's put it on that side. And we need 2 space. 1, 2. Bam. 1, 2. Bam. 1, 2. Bam. Perfect. Next up. Can we use a labeler? Yes. I think that's such a smart use for the labeler. Allowing you to change those by text. That's so smart in my opinion. Okay. So we need more arc furnaces, more chutes, and everything. We need one more IC as control unit for that. Interesting. They also made a small little small slit there and not just clipping it through. Nice. Yeah, and then I also need like an IC, like 1 or 2 IC housings for the automation of the furnaces. And logic sorter, we will see. I mean, they need to be programmed. I don't know. Can you program? Yeah, you can't program them with that tablet, which Would be cool, but you can't. Laptop doesn't allow me to connect up the things, right? That would be cool. But okay. So yeah, we need more chutes and arc furnaces. How many stackers do we have now? One placed? We have placed 5. And we still have 5 left. Okay. Yeah, that one is empty. Various things that we gotta do now. Drinking, eating, power, air, crafting, various things. So first things first, I would say. And let's grab that canister. Next up, turn those 2 machines on. And let's create some furnaces. Can maximum make 4 with the iron that we've got. So that is okay. Next up, getting rid of the pipes and pipe utility that we got there. I don't know where the iron sheet comes from, to be honest. But yeah, putting that there. Next up, filling up the canister. Oh, I forgot drinking. We got a pressure regulator already set up for that. Interestingly enough. But doesn't have a power cable connection. Interesting. Interesting. I'm gonna set up that. Oh, right. That. Oh, God. How am I gonna do that? Kidding me? God damn it. And a wire cutter. Eight thousand. If I remember correctly, 8,000 kilopascals. Okay. Now let's drink something. I'm already dying from it. Let's eat something. Potato. There we go. Yeah, now we need a little bit. Now we need more iron. Fuck, forgot to get rid of the iron sheet again. Okay. That one is still being filled, but it has a high enough pressure for now. Now let's grab those pipes, put them over here. Next. Getting rid of the iron sheet. And the frames and the steel sheets. We don't need those anymore. I mean, the steel sheets we may need later, but not right now. Let me put them over. Okay. Gotta turn that off. Right. The rest of the iron, which is only 2 grams, we can barely do anything with that. Let's smelt down a little bit of iron so that we can make the chutes and stuff.
Anti-critical.
Not anymore. Ah, wait. What does a filter need? Filter. I need a CO2 filter. 5 iron. Heavy filter. Carbon dioxide, 5. Okay, let's make a heavy filter. We can make an heavy filter. Need a little steel. Filter. Heavy filter, carbon dioxide. Invar and stellite. Invar, stellite. So with that, we then go outside. We gotta put that into our suit. Put the old one back. And yeah, and then we go from there. Okay. Okay, new filter, new air, we have power, we are fed, and we have drank something. Now then, oh, for God's sake, that thing was running. But okay, now we have a nice little system running, so we can let that output do its thing. Oh, we're gonna make sure that that the pressure is not too much. Okay, now let's, before we can do the iron, we gotta leave it like that and let it pump out everything. In the meantime, we gotta build the arc furnaces. Look at that. Nice. That is processing at its finest. I mean, at this point, to be honest, I kind of would have wanted that to be in base instead of outside of here. But okay. I mean, we can move it there once we have decided upon a new room, expanded the base so far enough, decided upon a new room where we can put down the SDB silos, because then I would combine that essentially a little bit. Then we have like one sorter array here for ores, and then we also have a sorter array here additionally for ingots, and then the output of the arc furnace and from this ingot sorter go into one stacker per resource, and then from the stacker into the SDB silo. That would be my idea. And maybe even a little bit more separated in a way, so that we could, instead of like preparing the room for that, so that we could, instead of having the arc furnaces being run by the splitters directly, also have an SDB silo as big buffer in between. So that means like sorter array. So that means we have like a sorter array, SDB silo, arc furnace, sorter array, stacker, SDB silo. Well, okay, and also a stacker over there for the entrance of the SDB silo. Of course. It's like stairs. But this here is essentially just a compact version of it, because the output here also doesn't get into SDB silos. They go into a vending machine. That was at least my plan. So yeah, this guy here needs an IC. We need a lot of chutes. And yeah, I need 3 more arc furnaces, it seems. Wait, 1, 2, 3, 4, 5. I only have 4 stackers. Where? Huh? 1 stacker is missing. Oh, no, wait, that's a sort. Hey, here are the stackers. Okay, sorters. Okay, yeah. I need 4 more arc furnaces. No, wait. 7 arc furnaces. I only need 1 more. I only need 1 more. Nearly empty. Something is buggy about that. I'm worried. Gonna check on 1.02 moles. That's a lot of moles. I think something exploded. No, because then volatiles would be there as well. Yep, It exploded. Pressure was too high. Or liquids. Could have been liquids. Damn it. But that's not an issue of our ICs. That was an issue of the furnace. So, we desire to get our steel done. It's already in there. And give me that steel. So, and with the rest of the heat, we gotta do a little bit of normal iron. Why is the filtration unit not pumping anything out of there? Or if it would, why is it so slow? I would say it burst somewhere else as well. And I simply haven't noticed yet. Nope, it's my script, it seems. And min treasure greater or equal R2 R1. Oh wait, it's storing. Ah, that's why. Shall be R3. Yep, now it's running. Gotta store again. Going to overwrite the script of the data you have on the computer screen. Overwrite. Let's also grab the IC from over there. Here we are using R2 and R3, okay. And export.
Toxin critical.
Okay, toxins. Not good. Okay, I'm gonna label those. Filtration scrubber 1 and scrubber 2. Then I'm gonna change that to filtration scrubber 1
Power low.
and scrubber 2.
Guys, my name is Kozluno, and this is the Copenhagen boat tour DJ mix. Here we go.
Yeah. Did something explode? It sounded like something exploded, but it's... that condensation is happening inside. It's warming up. It's warming up again. Okay. Stress is decreasing. Good. And as you can see, pollutants also decrease. So we just have to let that run a little bit. That will take a little bit. So it may be worth to let this scrubbing unit run. That's the air scrubber, yeah. It doesn't have filter though. Okay, never mind. Okay, so we got iron, we got steel. I need one more arc furnace. And then I need a bunch of chutes. And I need a shit ton of cable. Doesn't have any cable. Copper that we need for cable. We need another IC. And we need a deep ore miner. There's so much stuff to do. Okay, next. Deep miner. Steel, electrum, invar, and constantan. Steel, electrum, invar, and constantan. Constantan is over here. And invar. Invar, I think, is in here. Yep. No, wait. Invar. Yeah. No. One. Invar. One more deep ore miner. Deep ore miner needs 2 steel sheets and 4 electronic stuff. Oh, wait. How much? 12 steel sheets. Okay, not 2 steel sheets, 12. Okay, that's something we have to do then. So, there's that. That and that. Okay, and we need electronic parts. Iron, gold, and copper. Ah, there's a big chunk of gold. Okay. Oh, and there's also a bunch of gold inside. Okay. Yeah. I mean, we need integrated circuit, steel, electrum, solder. Okay, that stuff is all in here. Electronic parts. In the meantime... Ah, right. Toxins. There was something.
Toxin detected.
But I have to drink anyways. I am scrubbing already. It just takes some time. 1 to 12%. Okay. Nope, we don't need one more. So, okay, now you please put out all your stuff. Okay, so steel, iron, and copper. Copper, iron. 4 electronic. And steel goes back inside. Steel sheets. And for electronic parts. I've put the 2 in, so only have to check until that is 12. So now we got the electronic parts. Next up is cables and integrated circuit. Gold, steel, electrum, solder. Gold. Shit. Too many. Okay. 1, 2. Gotta put those away so that when we build that one, it's fully equipped, fully used up, and no residual in inventory. So steel, electrum, solder. Steel, electrum, solder. So we got electrum. Solder is over here, and we need a little bit of steel now. But we gotta trade it for the iron, because that guy doesn't need iron. And we need the iron here to create a bunch of chutes. Basic chutes. And we gotta make 1 or 2 ICs in here. Let's make 2. Just... we may need only 1. We could, like... we could address all the logic sorter. I don't know. Could try address all the logic sorters via a single IC, via batching, and same for the arc furnaces. Okay, but we're not done yet. Now we gotta make use of that copper, as we need a shit ton of cable to connect up everything. Like a metric ton of cable or whatever. Well, of combustion chamber, not a good idea because of stress not being the same for every chamber. What do you mean? Combustion centrifuge. What is not good? Didn't quite understand what you wanted to tell me, to be honest. As you can see, that's rather problematic on production of stuff, being able to hold that and stuff, carry it. So, now then, let's cycle through. Whee! Okay. So, let's connect up those here. Windows we can place at some other point in time when we've automated here most of that stuff. Then we get a bunch of iron automatically, and then we can create a bunch more chutes, and then we can go with that. Okay, let's also do the last deep ore miner. Gotta weld that shut now. Ah, I forgot to charge that guy. Then we need... Wait, no, we need cable and screwdriver. And now we need electronic parts. And screwdriver? Okay, and screwdriver. Okay, done with that. Perfect. Getting there. Getting there, gotta tell ya. Whew. Next up. Let's grab that. Those other 10 basic chutes. So, we've connected up all of those chutes here. Now, we could do that. And after that, we could do that, or the other way around. Doesn't matter. All needs to be done. Straight. The thing is, I want windows at the entrances of machinery. The problem is just that they require 2 chutes, and 1 chute requires 3 grams of iron. And that's hecking annoying. Okay, here is a little bit a special thing, because here we gotta do a junction with this orientation. Okay, why a junction here? Well, we need to connect the other deep miners as well. So that's why a junction there. Okay, next up is let me insert that IC pretty quickly. So just it's simply there. Yeah, those. We also need a shit ton of pipe. But okay, let's start slowly. That is power and data, right? Power and data, yeah. Okay. Now those are connected up. Next question is, where are the power connectors of those? The thing is, we need to connect both data and power. Okay. I guess the most logical approach probably would be to connect those two at least in that fashion. How I'm gonna connect those then along that axis, I'm unsure. Either I connect it to over there where we already have a long axis, or we do it directly. The question is, what consumes more wire? Especially, we also could like separate differentiate here because we have that side to connect as well. And there we go. And perfect. Over here, same game, and done. So all of the arc furnaces are connected up to their stackers, which is good. All the sorters are connected up, and those two are also connected up. Now, okay, the arc furnaces, they also, their logic stuff needs to also be connected. I guess. Yeah, I mean, okay, we are already running here along. Okay, but like one connecting from here to there. 1, 2. Yeah, 1, 2, 3, 4. I have to connect that twice because of the connection cost. 1, 2, 3, 4. Same value. The only difference is that if I'm here, I have it more easy to connect up to over. I have it more easy to connect up. Oh, I cannot. Interesting. I cannot go over here. There. So I have to let those guys run their own connections. Over here. Oh, no. Huh? Fuck. What? Yeah, okay, so like I cannot connect like that, but I can connect like that. And I have to do that with the ones over on this side, it seems. Okay, need more cable. It was very clear that I need more cable, but okay. So yeah, but it's obvious I have to connect them here like that. But how I'm gonna connect those, I'm unsure yet. I could connect them like that, or I could connect them like that. But I think it would be more cool if I connect them up like that, because then I can take out that cable, and then all of the arc furnaces are turned off, for example. But anyways, gonna sleep now and try to continue. Yeah, thanks for tuning in. I hope you enjoyed the stream. It was still a lot of fun. We made quite a bit of progress. Right? We did quite a bit of progress. Come on. Definitely. We did a little bit of programming, learned a little bit. And well, we worked on our deep ore stuff. A bit of atmospherics, so yeah, gonna continue on here now. As said, long stream today, like something like probably yeah, probably 45 minutes or whatever more. Probably not gonna program that thing, but the tubes maybe, but definitely connecting up the wires here so far. I mean, the rest is already done, so yeah. Shoots definitely. And yeah, connecting up here the wires. Producing the necessary stuff. Stuff like that. Maybe, okay, maybe we're gonna start with the programming of the stuff, but I'm not sure about that yet. What does the air say? Getting better. Getting better. Okay, so we need chutes. And we need cable. Oh no. Gotta put in a little bit of coal. While those guys are producing, wanna check out our scrubbing area. Looking good. Oh yeah, only 0.1%. Minimum stress.
Power low.
How they are blinking. Beep boop 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 beep boop. They're running continuously. Will take a bit of time until. I mean, okay. Also 0.643% here. Not too shabby, I would say. Okay, now let's grab those chutes. Let's grab that wire. We gotta eat. Temperature low? Okay, I didn't expect temperature to be low, to be honest.
Temperature low.
Why is it so cold over here? I don't understand what this here is doing to the temps. Oh wait, the pollutants probably go through and they take a lot of temperature with them. The liquids. I assume. Yeah, we need a better air conditioning solution. But not doing atmospherics now, I wanna do the other stuff first. One thing at a time. We did the last bunch of streams, the atmospheric stuff. And this stream, also a little bit of atmospheric stuff. Give me a break, a little bit, at least. Oh, come on! What about would just be question of how it's coded. Okay, so here we go. Let's continue wiring up that stuff. So now let's connect up that. Just as mentioned. Just like we talked about. The reason why we have to connect up the data in the data ports of the like those are the power ports, but the reason why we have to connect the data ports of the furnaces is that we have to manually activate it. Like you could make a small little logic stuff or whatever, but we have ICs. Let's go with ICs. We are ITler after all. Okay. Next up. Getting the connection across here and getting the connection across here. And all of that stuff is now connected up together. These here are not yet. So that's what we're gonna do next. I don't know about the data port if we need it, but yeah, let's go with that. Just for fun. Okay. Those are also connected up now. Let's make the wire go across here. Just like that. Next up, chutes. So at least the first deep miner is connected up. Hold on. A little bit too far. Here goes in a junction. Nope. In that direction. Straight. And corner. To be honest, I didn't expect us to connect all three. Yeah, I didn't expect us to connect up all three of those deep ore miners with the chutes that I got, but we did, so that is good. Okay, so that's connected up. I have one more left. Instead of a window, I could put it over there. For now. Straight. So yeah, we got that now. All of that stuff is connected up. Air power controller would be used over there. So what's left now is, I mean, the sorting facility and smelting facility is not done yet. I have still a bunch of sorters left, but for those I need to get rid of this stuff here so I can build it. The problem is that, so yeah, I have to get rid of this here so I can continue on the sorting facility. That's the problem. But also very important is, yeah, hold on. Okay. Okay. Now, wanted to get rid of that weird song. Okay. So, yeah, I need to expand it in that direction. But I can't do that. I want to keep that stuff here running. So instead, next step for this entire facility would be coding the IC. The focus of the IC being controlling the well, okay, before that, connecting up the centrifuge to the atmospherics. Hot and like fuel and hot both need to be connected. Once that is completed, then we can think about the next. Then we can talk about getting the integrated circuit up and running. Integrated circuit requires a bit of programming, and the first and it consists of three main steps. Step 1: controlling the combustion centrifuge. Yeah, controlling combustion centrifuge. Then step 2. I don't know if it's part of the IC or separately. I have to read up on that in the wiki. Doing the logic sorters here, programming those. And step 3. That's definitely something for the IC. I'm not gonna do it somehow else, and that is controlling the arc furnaces. I mean, I don't know if the arc furnace does have now a mode or whatever to automatically to automatically do this stuff, like a setting or whatever. There's activate. You can write to it a 1 and then it will activate. Okay. There is on, there is lock, and that's about it. Okay, so we still have to manually activate it. Clear memory. Logic slots. Yeah, okay. And connections. Should output. Yeah, whatever. Okay. So there's that. Those are the 3 IC chops that we have. Logic sorter, logic sorter, logic sorter, normal sorter. Oh, not enough battery. To be replaced. And logic sorter. Okay. There is everything set up now. Well, not everything. We still need the pipe of fuel and the exhaust pipe. So yeah, since I'm probably alone, I don't know. I mean, is someone here? The question now is, shall we do the AC unit or shall we do getting the pipe over and programming that stuff? I mean, we need that. We need so much pipe. Let's just let it run a little bit of pipe and then check upon the atmosphere stuff. Ice cold. Steel and silicon. Insulated pipe. Let's make insulated pipe. You know why? That's more efficient than the other option. The normal pipe. Kinda. Because it uses steel. Oh, well, okay, no, it's not efficient because it also uses silicon. Okay, never mind. But we have a bunch of silicon that we can easily make use of. Yeah. But like, it uses steel instead of iron. That is kinda more efficient as... Yeah, like iron, like it uses less iron essentially, but instead uses coal with like 25%, which is totally okay with me. So let's go with insulated pipe then. Oh wait, hold on. Pipe. Yeah, that one uses only 0.5 grams iron. Okay. Never mind. Gonna use normal pipe for now. Okay, it's really freaking cold. But it's even colder over here. Yeah, it's really cold. Oh, that's why. God damn it. You have an output pressure control. Okay, that's probably condensation stuff. That's probably why it burst. It's not a pressure thing, but condensation. Condensation problematic. God damn it. But okay, I gotta get a furnace in and heat it up.
Power low.
Crate? Oh, I get it. No, don't need it. Okay, I have an idea. Let's stop that for now. The furnace is probably already over there. Some more frozen carbon dioxide. Okay. Yeah, here it is, furnace. Wrench? But now you need to weld it. Yep. Okay, and now they need now we need a little bit of volatiles and yeah. Or other option, routing that over. I can spare a little bit of pipe now. Okay, but I think it's better to try out that. Like, get that stuff a little bit over here. So that here is input. So that means we go from here to there. And here we go towards the output. Okay. I'm working on trying to get everything heated up now. Oh wait, there are a bunch of moles in there, but not ignited. Trying to heat up everything again. Not that easy. I mean, we have a backpack full of ice, but mostly oxide and yeah, oxide and nitrogen. Not really much volatiles. Let's go outside and grab a little bit of volatiles.
Hydration critical. Temperature critical. Temperature low.
Gonna have to get away of the base a little bit. And then I'm gonna try to get some volatiles. All the way down there are a bunch of volatiles. Over there it's a little bit more, a little bit closer to the surface, I thought. No, it's in a mountain. But okay. Still better than nothing.
Power critical.
Yeah. I'm gonna finish up that job here though. First, and then I'm gonna go back to base. Got a bunch of volatiles. That should be enough for some time now. Come on. Doesn't let me through. Wait, lenses off. So, first things first, switch to backpack. Next up, gotta connect that and turn on the machines. Error? Error. Ah, no pipe, that's why. That's why error.
Hunger caution.
Okay. Trying to drain the furnace so that I can then dump in a little bit of ice instead of fuel mix, and then go with that. High pressure, much hot. That's what we want to see.
Thanks for watching, guys.
So now we're scrubbing a little bit again. Just to make sure that everything's working right. Okay, looking good. What does the temperature say? Okay. Still hot, good. Not scrubbing much. Ah. Not connected up. That's why not scrubbing much. Let's try to fix that. Hmm. Temperature's getting better. Air quality is getting better. Very happy. Ugh. Yeah. Sneezing. Sneezy sneeze. So, okay. I love how that our scrubbing stuff is working. Temperature's still rather high in this room, sadly. But pollutants went down drastically. Let's get that hot again. Is it possible that pollution has like a really high heat capacity? Latent heat 2 kilojoules, specific heat 24. .8 joule per Kelvin. Latent heat 2 kilojoules per mole. O2, oxygen. Yeah. It can carry a lot of energy. Which is a bummer. Heat is looking good. Air scrubbing becomes less and less effective. It seems. Yeah.
Hunger critical.
Hunger critical, gotta eat something. Temperature's still very low around here.
Hunger caution.
Gotta leave it. This should have a lot of energy now, as it's quite the high pressure and he's still quite hot, so the heat shouldn't decay that quickly, and it has a lot of energy it can give the air, so yeah. We just effectively we just have to wait. So it's now slowly getting rid of that liquid pollutants. It's heating up. Okay, so
Power low. Filter low.
Pollutants are looking okay. Could be better, but it's not that bad. CO2 is even better. So now we just gotta wait. Oh shit. Problematic.
Temperature low.
He still has a lot to heat up after all.
Toxin critical. Click, clack, click, clack, click, clack, click, clack. Lovely. Getting slowly better. Temperature critical. Temperature low.
So now since we are outside, like the main point of going outside is filling up our coal power. But yeah, since we're outside, we could also do that. Setting up the pipes. Okay, wait. Corner. 1, 2, 3, corner. Corner. 1, 2, 3, corner. Perfect. Okay, let's go over there. Let's go over there. Ouch. I hate that. Exit. But I guess, okay, that's that's a good thing anyway. We're gonna end the stream now. It's late. Next stream, very likely tomorrow. Plan for that stream. We're gonna continue on, yeah, on our deep miner facility, or handling stuff and shit. Yeah. Working on that. That's the plan for tomorrow. For next time, essentially. So, retrospective. What did we do today? Well, we tried a little bit of IC programming, or learned a little bit of stuff there. For programming some safety mechanisms into our atmospherics on the underground, and yeah, right. So that. Then what else? Yeah, we also got to work. Yeah, we had a little bit of issues, some exploded pipes and stuff that drain, and our rooms cooled down drastically. So we are right now working on a fix for that, heating up the room again using a furnace. So like right now we're trying to heat up the room again using a furnace. And yeah, trying to figure out what the reason were. So like pollutants have collected, I guess. Like the cooldown was caused by a was caused by the exhaust pipe that goes up in goes to a passive vent to the air that has broken, probably due to frozen or liquid pollutants. At least it seems like that one causes a bit of stress, and I can imagine that because that was the countermeasure of another pipe break that caused the inner atmosphere to get a lot of pollutants. So that's why we activated the scrubbing machine. And the scrubbing machine and let the system get rid of a lot of pollutants, essentially. So yeah, and that's a problem. The first burst was caused, I don't know why, maybe also again by some condensation of pollutants possible by the advanced furnace, by the dump of the advanced furnace. So yeah. Maybe gotta check up on the pollutants. They're trying to add a drain here and there, getting rid of the liquid pollutants more quickly, or like having a temporary storage, essentially. That's also something we could check up on, having a temporary storage with a bit of volume there, because that's the point of the liquid pipes. After all, they have a bunch of volume for liquids, which the pipes do not. So yeah, gotta think about that. Other thing is other big thing that we've worked on is now the new deep miner facility. So we've built 3 new deep miners, fully constructed. We built a lot of logic sorters, a lot of stackers, a lot of arc furnaces, and made a sorting facility and ore smelting facility, and we are using the combustion centrifuge. We decided on using the combustion centrifuge, and now we have created a small little facility for so that we can connect up 4 deep ore miners to one centrifuge, to one combustion centrifuge that's controlled by an IC. And yeah, the IC controller we haven't programmed yet, so the entire facility doesn't work yet, and there is still some construction left. The old deep ore facility, deep miner facility, has to be dismantled so that I can continue. I need I think 4 more sorters and 2 more arc furnaces. Yeah, and a few stackers. The stacker outputs are also not connected up yet to the vending machine, so that's also something that we might need to be should be interested in. And the combustion centrifuge itself is also not programmed, not running. Same as for the arc furnaces, the sorters and stuff. That's all of that has to be programmed first. I'm very interested in logic sort, on how they operate, how that works. But for now, that's how it goes. What else? I don't think there's anything left. Don't think so. That's what we did. I mean, yeah, was quite a bit of progress, I would say. Was quite a bit of progress. Excited for tomorrow, because the plan for next time is, well, also again ensuring heating up the room and stuff. That's the priority 1. Ensuring that we get back the heat into our room. And after that, we gotta continue building on the pipes for the combustion centrifuge. We also then probably also should look on for the pollutant drains and temporary liquid storage for that thingy, yeah. Of the exhaust pipe and the waste pipe, essentially. And yeah, then we're gonna try to work on that, I would say. When we get making that, and when that stuff is done, when we fix the atmospherics for the combustion centrifuge, then it goes on to a bunch of programming the combustion centrifuge, programming the sorters, and the arc furnaces. All of those need to be programmed. I don't know what what the order will be, but I suspect that my plan is to first do the sorters. Or maybe not. I don't know. I don't know what the order will be. We will see that next time. So guys, then I will say thank you so much for watching. I was Pinocchio, and I say bye bye until next time. And as always, keep coding!